Today we're going to continue our conversation on geometric sequences and talk about a couple different things. One of the new things we're going to talk about is find the geometric mean. We'll talk about that in a second. Also, we want to double check that we make sure we can determine whether or not a sequence is geometric. And then if we're given a bunch of sequences, can we tell whether it's geometric, arithmetic, or neither, even if we're not in the unit of geometric or arithmetic? The first thing I want to talk about is just remembering that the geometric sequence has a common ratio. That's the number that's used to multiply to get from term to term. So it's a common ratio multiplier where arithmetic was a common difference, the number we add or subtract. We want to first talk about finding the geometric mean. Geometric mean, or the middle number of a geometric sequence. They have to tell us that it's a geometric sequence. So we have a number here. We skip over, we don't have this number, and then we have another number. The number we're looking for, we're always going to say is AN, the number that we're looking for. Just some notation here. This is a to the n minus 1. That's the term before that. If I have 8, 1 less than that is 7. So if I have this term, 1 less than this is the term before. This n plus 1 means the term that's after that. The formula that we'll be using to find the geometric mean is taking those two terms that we're given, the term prior and the term after the term we're looking for. We're multiplying those together, and then we're going to take the square root to find the geometric mean. So if we look at an example that I already have done here, we have a 2, we have blank, and then we have 25. We're looking for that number that goes there in the middle. Remember, it's geometric. So we have to use this formula. It's different than finding the arithmetic mean. We're going to take the two numbers that we have, the 2 times 50. Inside a square root, we get 100. Well, the square root of 100 is 10. So 10 is this missing number right here. And if we double check this, remember to find R, we take the second term divided by the first term. If we take 10 divided by 2, we get 5. So if we take 2 times that 5, do we get 10? Yeah. If we take 10 times that 5, do we get 50? Yeah, so it just confirms that we do have the correct number there. Let's go on to a couple more examples. We have this, and again, they have to tell us it's geometric up here. So we have to say that it's geometric. We have 4, then blank, and then 64. Well, to find the geometric mean, we're going to take, it's very simple, take those two numbers, the one prior and the one after. We're going to multiply those together inside the square root. Well, 4 times 64 is 256. The square root of 256 is 16. So this 16 is the number that goes in the middle there. So well, let's double check this. So take that second number of 16 and divide by the first one. That's going to give us our R value. 16 divided by 4 is equal to 4. If we take 4 times our R of 4, do we get the 16? Yes. If we take our 16 times 4, do we get 64? Absolutely. So it's a double check that we've got the right answer. Look at the next one. We have 5, blank, 45. Well, it's real simple. 5 times 45 inside the parentheses. 5 times 45 is 225. We take the square root of that, and we get 15. And 15 is the number that goes in the middle there. We look at another one. We have 100, blank, 25. This one's going down. That's okay. Doesn't matter if it's going up or down. We can still find it. So we take our 100 times our 25 inside the square root. 100 times 25 is 2,500. We take the square root of that, and we get 50. So 50 is the number that goes in there. Let's double check this one because it's a decrease there. So again, to find R, we take our second term divided by our first term. 50 divided by 100 gives us 1/2 or 0.5. If we take this 50 times 0.5 or take half of 50, do we get 25? Yes, we do. We'll look at another one here. This says 0.2 blank and then 0.032. Well, just like before, we're going to take those two numbers, the 0.2 and then the 0.032 inside the parenthesis or inside the square root. When we multiply that, we get 0.0064. We're going to take the square root of that and get 0.08. 0.08 is the number that goes right there. Our last one for this right here is this 1/3 blank 1/12. Oh, inside parentheses, 1/3 times 1/12. We multiply that. We multiply fractions as top times top, bottom times bottom. I get 1/36. I can take the square root of that, but both of these numbers, 1 and 36, are perfect squares. So I'm going to take the square root of the 1, which is 1, the square root of 36, which is 6, and I'm going to get 1/6 as my middle term. If you were to take these and multiply them on your calculator and take the square root, well, first of all, if you multiplied those, you'd get 0.02777. And then if you took the square root of that, you get 0.16 repeated. And those are the same values. I just did a different way because I knew this was going to work out nicely with the square root of the 36. Now, what if we're given a sequence and we're asked, is this geometric? We don't know for sure. So we got to try and see if we can find R and then see if it works out to get the terms and then actually give the next two terms, what we're asking here, find the next two terms. Well, I'm going to see if this is geometric. Remember, geometric, we're going to get an R value, and we're going to take our second term divided by our first term. We're going to take our -12 divided by -3, and in this case here we get 4. Let's double check. If we take our -12 times this 4, do we get -48? Yes, we do. So yes, geometric. And then if I want the next two terms, I'm going to take our -48 times 4 to get -192. Then I'm going to take that times 4, and I'm going to get -768. So our next two terms after the -3, -12, -48 are -192 and -768. Another one here. I have 81, 27, 9. Well, I'm going to check. R, second term divided by first term. If you divide that out, you're going to get 0.3 repeated, and I would go into your calculator, see if you can change that back to a fraction, or see if you can reduce this fraction. And this is actually 1/3. So now, if we multiply by 1/3, if we take 27 and multiply by 1/3 on your calculator, yes, you will get 9. So yes, this is geometric. And then to get our next terms, well, we take our 9 times 1/3, and we get 3. That's our next term. And then take that 3 times 1/3, and we get 1, and that's the next term after that. So our sequence would really go 81, 27, 9, 3, 1, etc. Next one here, we have 6, 7.8, and 10.14. We're going to see if we can find out an R value. Take our second term divided by our first term. And when we do that, I get a value of 1.3. Okay, let's take our 7.8 times 1.3, and let's see if we get 10.14. I do that on my calculator, And yes, I do. So yes, this one is geometric again. Then to get our next two terms after that, I'm going to take our 10.14 times my 1/3, and I'm going to get 13.82. So that's the next term. Then I'm going to take my 13.182 times my 1.3 again, and I get 17.1366. Now, when you get numbers like these, please give me at least the first two decimal places. So here we could have this as 13.18. This one here would be 17.14 because the 6 would round this one up. The last one, we're trying to see if we determine this is geometric or not. Well, I'm going to say R here, and I'm going to take 8 divided by 4, because it's second term divided by first term. When I divide that out, I get a 2. So now I should be able to expect to take the 8 times 2. And do I get 24? No, I do not. So not geometric. That does not mean that it's not some type of sequence. It's just saying it's not geometric. And actually, if you look at this, if you go from 8 to 4, I have to multiply by 2. Then if I go from 8 to 24, I have to multiply by 3. So I multiplied by 2 first to get from 4 to 8. I multiply by 3 to get from 8 to 24. Then if I take my 24 times 4, I do get 96. So you can see a pattern there. The next one will be times 5, then times 6, and times 7, and so on. So it is a sequence. It does have a pattern, but it's not a nice specific kind. It's not geometric. And lastly, we're just going to be given some sequences, and we're going to be asked, is it arithmetic, is it geometric, or is it neither? So if we check to see if it's arithmetic and it's not, we're not going to automatically say neither. We're going to check to see if it's geometric. Or if we check to see if it's geometric first and it doesn't work out, don't say neither right away. Check for arithmetic. So this first one right here, doesn't matter what we check. I'm going to check for arithmetic first. So that means I'm looking for D, a common difference. And that member is taking the second term minus the first term. If I take 8 minus 16, I get -8. So that would imply in order for it to go from 8 to 8 to 4, I'd have to subtract 8. Well, if I take 8 minus 8, I get 0 and not 4. So I can say no with the arithmetic. Now I want to check geometric. Remember, geometric is the second term divided by the first term. If I take the second term, 8, divided by the first term, 16, I get 1/2 or 0.5. Well, if I take 16 times 0.5 or take half of 16, do I get 8? Yes, I do. So I can multiply by that 0.5. If I go from 8 to 4, can I multiply by 0.5? Is 4 half of 8? Absolutely. So this one over here is geometric because it has this common ratio of R right here, which is 0.5 to get from term to term. I'll look at another one. I got 16, 12, 8. I started with arithmetic here. I'll start with arithmetic, trying to check arithmetic again for this one here. Remember arithmetic, we want D, and that's the second term minus the first term. 12 minus 16 is -4. So if it indeed is arithmetic, that would mean I would have to take 12 minus 4 to get 8, and I do. So there's no need to check and see if it's geometric. It's already determined that this thing is arithmetic. I found a value of D, and it worked to get the next term. So we can say that, yes, it's arithmetic. Okay? Get to another one here that says 1, 2, 8, 48. Well, I'm going to check to see if it's arithmetic first. I'm going to look for a common difference of D. I'm going to take the second term minus the first term. I get 1. That would mean if I go back up here and I take my 2 plus 1, I should get 8, and I do not. So this one is not arithmetic. Let's check geometric. Remember, we're looking for a common ratio. I'm taking the second term divided by the first term. Second term divided by first term gives us a value of 2. That would mean that I multiply by 2. Well, 1 times 2 gives us 2, but then if I take 2 times another 2, I don't get 8, I get 4. So no, it's not geometric either. This one is neither. It's neither geometric nor arithmetic. I have this one down here. It's got some crazy decimal places. 5.63, 5.76, 5.89. I don't know. Let's check for arithmetic first, just because that's what we've been doing. Looking for a common difference here. Take the second term, 5.76, minus the first term of 5.63. When I subtract that, I get 1.3. So right now it looks like our common differences could be 1.3. So I go back up here. If I take my 5.76 and I add 1.3, do we get 5.89? Yes, we do. So this is yes, arithmetic. That concludes this lesson.